This session has been organized under the aegis of the Manufacturing Expert Committee of BCIC. We would like to specially thank Mr. Prakash G, Chairman of the Expert Committee and Vice President Technical of Toyota Kirloskar Auto Parts, and also Dr. S. Devarajan, Mentor of the Expert Committee and the Senior Vice President Production Engineering, TVS Motor Company, for curating this session for the benefit of all of us. The speaker for today's session is none other than our President, Mr. T.R. Parshunam, who is also a President and whole-time Director of Toyota Industries Engine, and Dr. S. Devarajan, Mentor of the Manufacturing Expert Committee of BCIC, Senior Vice President, Production Engineering, TVS Motor Company. They will be making a presentation on the core ideology of TPM, why companies need to adapt, and share the insights on why, what, and how TPM will be leveraged to enhance competitiveness in greater organizational effectiveness. And this will bring and enhance the contribution to Atmanirbhar Bharat and Make in India initiatives. The session will be moderated by Mr. Prakash Ji, Chair of the Manufacturing Expert Committee. On behalf of BCIC, we express our sincere thanks to our President and Dr. Devarajan for accepting our invitation to address on this important subject. We would also like to thank all the participants for joining in today's sessions. We request all the participants to kindly mute your mic and webcam option. This is to enhance and keep the bandwidth strong, as well as avoid any disturbance in the background. Please post your questions on the chat box. Speakers will respond to the question during the session. Or you could raise your hand and we will be able to facilitate your questions to be brought to the speaker. May I now invite Mr. Prakash Ji to set the theme for today's session and the context and to take forward the session. Thanking you all once again. Over to you, Mr. Prakash Ji.
Thank you, Prithvi, for wonderful introduction of the speakers and also the welcome all the participants for this session. And we are very fortunate to have the very experienced, I think, well-known personalities and the leaders of the industry for giving us this kind of a session to all the participants. Today's, I think, we see about 100 plus participants, and they are very keen to understand. And in terms of TPM, I think Prithvi San has done a very good job of introducing about TPM. So I don't have to touch upon that as far as the initial theme is concerned. And the key point here is that we hear a lot of TPM being done by many companies, but from the leaders from the leading industries, what it means is a TPM. Now, some of the companies do the TPM in probably in silos and pockets, but I think as a whole, how it is going to be useful to the organization, how it needs to be looked at also, right? I mean, through the kind of the people who have really hands-on into this kind of a TPM activities. So we have with us Dr. Devarajan, who is working in TVS Group for the last 35 years or 40 years. I think he is a Senior Vice President of and heading the production engineering and new technology in TVS Motors. He has worked in setting up facilities of press shop, weld shop, painting shops, heat treatment shop, I mean, machining of steel, aluminum, assembly lines, leading many projects in TVS Motors, TVS Electronics. Presently, is concentrating on lean manufacturing systems, automation, digital manufacturing, TOC, TQM, TPM, and JIT implementation in TVS Motors. He actively participates in NITIE, IMTMA, CII on board of studies in engineering and management institutes. He has represented Karnataka State and Bangalore University in table tennis. Holds degree in doctorate in manufacturing systems engineering from University of Warwick, UK. He was awarded a prestigious Rolls-Royce Award of Excellence in Manufacturing Concepts and Implementation in UK. And he was also awarded a Thought Leadership by Automotive Manufacturing Solutions UK. So this is a brief about Dr. Devarajan, and he will be initially taking the session. And we have also our president of BCIC, Mr. Parshuraman. He is a whole-time director of Toyota Industries Engine Private Limited. He also actually is an MS in Technology Operations from BITS Pilani, management programs from IIM Bangalore, Master Certificate program in Gemba Kaizen and JIPM, Leaders Development Program at Toyota Motor Global Learning Center, Mikabe, Japan. He has over 35 years of experience. He has also worked at Toyota Kirloskar Auto Parts. He has a lot of involvement in industries bodies, starting with the BCIC. Now he is a president. Earlier to that, he has headed many committees, I think right from 2009 till now. And he was a chairman of Industrial Committee for 3 successive terms. He was a mentor for Human Capital and Services. He was also member of CIA National IR Council, Karnataka State Council, convener of Manufacturing Panel, co-convener of HR. I think the list is endless. So, and others. I think he was also advisor for National Prototyping Society of India, life member, past chairman of Quality Circular Forum of India, frequently invited speaker at national and international workshops to talk about global manufacturing best practices. He closely interacts with the very high senior government officials and trade bodies. Participated in the Global Science and Technology for Society Forum at Kyoto, Japan, as a panelist in creating high performance organizations at IIM Bangalore. I think this is a very, very short for Parashuraman's introduction and profile. I think this is, if you Google Parashuraman, you will get much more about him. All his videos are available there. So people who are interested definitely can also get more of it. But today, I think he's going to run us through to the real core of TPM in Toyota, how it is actually practiced. And before I hand over to Parashuraman to start the session, I invite Dr. Devarajan to take over the session.
Thank you very much, Prakash. Thank you, and welcome, Parashuraman, too. And good evening to everyone. I'd like to share my slide. Uh, is it visible?
It's just, yeah, it started. Yeah, it's visible.
Okay. Okay. Good evening, every one of you. I know the topic of competitive manufacturing is very, very valid today, and the changes in the business challenges is very much relevant today. And we're going to talk about TPM, and Parasham will take much more detail into TPM in 5 years. I will talk about how to uh, see how is the change happening from previously to today, and finally, how we can be competitive in manufacturing. So, slide is not moving. Yeah. Yeah. So, in terms of, I'll try to talk about automobile industry, changing situation, and what are we trying to do after COVID, and what are the applications, and how we can work together. I see a lot of participants here who are our customers, who are our suppliers, and I really like to share some of the experiences what we have. So today, as all of you know, mobility is life, and for which automobile industry is a backbone. And for auto industry, it contributes to GDP in a major way, around 7.4% and 35% of manufacturing GDP. India leads in the production of automobiles. I think we are the leader in two-wheeler and very close leader in the four-wheeler too. And we have to depend upon many of the suppliers in for the OEM. 60-70% parts come from OEM. The main change is on the younger generation. We have n is equal to 1, where younger generation, each customer is demand is different. And of course, the emission norms have changed from BS4 to BS6 and further. Future is going to be EV, how we can coexist with IC is going to be the area. A lot of electronics coming to automobile industry. And hence, many of the application of TPM, TQM are very key for our survival. So many of things which we know, how we are applying this and how we are taking to the next step to talk about a $5 trillion economy is all depends upon us and how we are implementing it. So, as I said, GDP is definitely growing, and probably we will touch around 12%, probably automobile industry share, and Indian share as well is growing up. At the same time, the opportunity in the local market and the export market is also increasing. And in fact, after we reopen back from COVID, the demand is also higher. And we are trying to see how both the exports and indigenous manufacturing we can cope up to the demand. So let us look at what is happening in the industry. So if you talk about customer, the QCD is definitely constant. Earlier, the quality was on percentages. We said, okay, we can manage it percentages. Now we have changed to PPM. And future means near future now, it became zero defect. And similarly, the price earlier was on the profit plus cost. Now every year on year reduction. Now we're talking about what value the product can give you, what value the product can give to the customer, and he can pay for it. And definitely, once we have to the inside the factory, how you can extend to the suppliers. Same thing extend to the supplier, same thing extend to the dealer to get zero defect, how we can increase the value and on time delivery. So why it is so important is around 60 to 70% is the material cost. So it's very important that not only our factory is improving, we should ensure that the supplier also is coming up, tier 1 and tier 2. So coming back into the supply chain management, earlier it was supply of parts, now changed to small lot. But I think very near n is equal to 1, the production has to be as per the demand. Similarly, as based on the customer, we can accept something, but now it is zero defect from the beginning. To do all the things, how we are trying to do agile and how we are able to apply variety to our products, then only we can survive in the current situation. So there's a transformation in the factory, transformation in the supplier area. Now, coming to the logistics. So it was earlier a batch production, now produced as per demand engine. I think many of you are applying the milk run, but can we have supplier sustained inventory and deliver it to our factory and our lines? And many of the things are coming into data capturing and analytics. That is, payment is made as soon as the delivery is made to the line. So the logistics, which are constitute something like 30 to 40%, is also a very, very important part to apply many of the tools which I'm going to talk about. So what's going to happen in the next 10 years? According to IBM study, it will be more change than happened in the 50 years before, and probably next 5 years itself. So we are in an area where we have to accept change. We have to accept new tools to apply to overcome and implement many of the changes inside a factory. Inside a factory, inside a dealer end, inside a supplier end. It's end-to-end changes which is needed. So what are the key challenges? One is we all are in the market, we are in the business to make money. How? We have to reduce cost. Do we have control on the final product price? Naturally, we don't have because customer decides the price and the competition forces decide the price. Do we have control on the input prices? You have to think because raw material constitutes something like 80%. We don't have control even the steel costs. So we have no control on the final product cost and the input prices, but we need to make money. How? Only around 10 to 20% is our control, but even the salary is not in our control, it changes. The main thing we are trying to say is to reduce waste. In all our areas, in all our work today, how to reduce waste is the key factor we are all working to. So there are different types of waste, starting from the today, if you're working from home, unutilization of the employees, overproduction, and waiting time. A lot of wasteful time is in terms of inventory. Transportation, I talked about the transportation cost, excessive movement inside a factory, outside a factory, and a lot of importance not given to the motion ergonomics, and of course the quality. So all the waste we need to attack. We need to see how to reduce. Similarly, what are the type of losses? Losses inside a factory includes which can impede the equipment efficiency, like failure losses, startup losses, minor stoppage losses, speed loss, defective areas, downtime, and in terms of production resources, again, operating motion loss, logistic losses, and of course on the tool breakage loss and the yield loss. So to work on these losses, to work on the wastages. We are trying to talk today. There are many tools available. For example, JET, we have got Lean, TQM, TPM, SMED, and all the new tools, which are all the existing tools, but all are interlinked to improvements. And all are linked to business-oriented manufacturing. I talked about the business of making money. So all the model system, whether it's flow manufacturing or low-cost automation, simple automation, quick changeover, visual, are all towards business-oriented manufacturing. And one such tool is TPM. So the base for all the improvements is a teamwork. We all know teamwork is a mantra which talks about the workmen, the managers, senior managers, and all are TEI, total employee involvement, and 5 years. Application of JIT, TPM, TQM is the main mantra for success. And hence, TPM becomes a very important tool for all of us to implement. And the base for all the improvement activities is total employee involvement. And of course, on the 5 years, of course, on the Kobatsu Kaizen in terms of the Kaizen's implementation, autonomous maintenance, plant maintenance, quality distortion or the quality maintenance, new product development, training and education on a continuous basis, office TPM in a regular way, including the logistics, safety, health, and environment, to improve what? To improve productivity, quality, cost, delivery, morale, and safety. This is the TPM pillar. So, what I talked about the challenges in the industry, coming back into improvement of our reduction of the waste, reduction of the losses, improvement of the 5 years by involving the total employee involvement and bringing the TPM. So today's topic will talk about TPM and 5 years and implementation of this in the industry. So if I extend further, what is total productive maintenance? In a short time, earlier, there used to be separate operator and separate quality check and separate maintenance person even for small improvements. Now, it's changing to I operate, I check, I maintain in TPM, in productive maintenance. And in the near future, if we are on the very near future, I operate to deliver as per demand. I proactively work towards checking and give quality level. I maintain it by bringing IoT and data capturing. So the changes from separate operator to I operate, I check towards the new areas of IoT, but the basic is productive maintenance or TPM. So this is the way I just wanted to extend to say how we can go from now to the near future. Similarly, if you look at the 8 limbs, earlier 5 years, I told about the first limb of 5 years, we had a separate team. Now what's happening, each area is maintained by an individual and a team. In the near future, shine 5 years and business benefits are shown even in 5 years. So it's important to know there is business benefit including 5 years. In terms of the Kaizen, Kobatsu Kaizen, we are trying to earlier practice. Now it has increased the level, going towards digital and visual KK. That's the change happening in the second limb. Third, in the JH in terms of the operator level, involvement of everyone, including the manager model, and seamless transition to the suppliers, which will give the benefit to the end-to-end. Similarly, if you go towards planned maintenance, earlier it was by the maintenance team, now done by the operator himself, I maintain, and linked towards IoT for the machine proactive checks. Quality in terms of the QM pillar, earlier the quality staff and inspection for approval. Now operator does the check, ensure zero defect, and extending to all the suppliers. For the new product, how you can bring the learnings from the beginning and how we can incorporate this from the beginning and seamless interlinking with PFME and DFME. So what is happening is it's becoming like a system. We are able to implement, sustain, and then grow in the development of the industry itself. In terms of office TPM earlier used to be separate from the factory. Now supplier, office, logistics under TPM brought into TPM and linking with IoT in the near future. Environment, earlier government regulations. We used to meet the government regulations, we were very happy. Now, environment and safety benefits are seen, and talking about extreme sustainability for community and safety. And total plant maintenance as a total productive maintenance changed to total profit management. This is the way in which the entire changes happening in TPM is going on in the future. And because of this, even a machine tool industry has changed from simple SPMs to flexible to a chain setup to deliver in this to one, from quality control to process capability to zero defect, and from batch production to agility and variety in our lines. And the next is on IoT based end to end improvements, sustaining zero defect, proactive participation in the new product, and bring new technology. I was talking about EV technology. How to bring new technology from the OPM in the OEMs, and how to integrate TPM, TQM, and Lean into to make the Toyota system or TPM TV system, and capturing data analysis and improvement to get the benefit for the business. So I think I'll stop here, and probably Parashuraman can take up to the next level, and then I'll come back to you on each limb of TPM.
Thank you, sir.
Thank
Thank
you.
you very much, I think, for setting a very good overview of the TPM session. And while we could get the overview now, to actually make it happen, we need to understand the details of it. So I think I hereby request Mr. Parashuraman to uh, take over the session, sir. I will now start sharing. So just a minute. I think.
Yeah, thanks,
Hi, Lansir.
Prakash ji. Thank you, Dr. Devarajan, for a
Thank you.
wonderful insight. It's made my job much simpler. Yeah, very good afternoon to all of you. You're able to hear me?
Yes, sir, we can hear you.
Thank you so much. First of all, greetings to all of you. And I'm very happy as the president of Bangalore Chambers, I have an opportunity to, talk as a speaker. In fact, all the meetings in this year, I've been introducing speakers and welcoming the gathering. Now I'm, participating for a change as a speaker. So I'm very happy. And TPM is my very favorite subject. In fact, at my B school, I did the project work on TPM. And I always call it as not total productive maintenance. I call it as total profit management or total people management or total participative management, so on and so forth. I think productive maintenance, okay, I think not just maintenance, it is a sigma of complete effectiveness of the entire operations. Even if you increase 1% OEE, the overall equipment effectiveness, the entire operations go up and ultimately results in the profitability of the plant. Therefore, this is the beginning. Then next slide, please. Yeah, I think TPM is a paradigm shift. In fact, this is a very big topic. I think it needs 3 to 4 days, to be honest, even to touch the basics. But let me try to do what I can do in the next 1 hour, 1.25 hour. Then we can look into some kind of a Q&A. So we go to this slide. What it means is the old thinking, I use, you fix it. Like I use means the manufacturing guy says, I use the equipment. And any problem, I request the maintenance to fix it. So in the TPM, it is a combination. It is a teamwork. So we maintain. I think this is a massive change in basic thinking. So this is where the whole thing lies. Everything they used to call maintenance, and manufacturing was a silo. Today, manufacturing is able to do the basic lubrication, oiling, and cleaning, and basic activities which we are going to discuss. Therefore, we can enhance the operations effectiveness, reduce the manpower in maintenance, and add more value as an organization. Next. So basically, TPM is a method to maximize equipment effectiveness through total employee involvement. As I said, it's a collaborative approach. And basically, it means management together with the shop floor production associates and the maintenance team. You can see the right side. The car as well as the driver, both should be in the top shape to win the race. Therefore, the car should be in top condition, driver also should be in top condition. Then you can win the race. So if you look at the synonyms, on the top you can see the baby's photo and bottom machine. So machine is something similar to the baby, and parents on the top, they are something, they are nurturing. I think here the operators, parents are similar to operators. So how the parents take care of the baby, the operators take care of the machines. That is the meaning. And the role of physician is nothing but maintenance. Whenever there is a problem, diagnostics or problem solving, the physician or the doctor enters. Therefore, this is a major shift in the thinking way. So what it means is accountability at low cost. Next slide, please. Yeah, this is a very interesting slide. If you really look at, the problems are hidden below the water level. It is like a glacier. So the many problems are hidden and invisible. So what you see is the tip of the iceberg. Failure is what we see, but is only the tip of the iceberg. And invisible problems, minor machine defects, are generally unnoticed, but the cause of the problem or the mechanism of failure is invisible. So you can see invisible issues like contamination, wear, leakages inside the machine, deformation, cracks, improper temperature, backlash, vibration, flaws, corrosion, loosening, etc., which are not visible or less visible. Next. So when I look at the TPM evaluation, the evaluation goes like this. In those days, before 1950s, 60s, we used to have the breakdown maintenance. Typically a reaction maintenance. Whenever the machine breaks down, immediately you call the maintenance guy and they'll come and fix it up. Then there evolved the preventive maintenance, the late 60s. So even before a failure, I think some kind of health checks happened in the machine. So it's a kind of a preventive mechanism. Then corrective maintenance. I think this is very important. And therefore, you proactively forecast certain kind of failure depending on the trend of certain parameters like the wear or the kind of temperature or the current flow, many things. Then you proactively try to take some activities in a planned way. That is the corrective maintenance. Of course, the corrective maintenance sometimes could be, corrective breakdown maintenance as well, because you don't have many spares and the machine has to stop. But you cannot change those parts until the machine stops. But mostly corrective maintenance is more of a proactive nature. Then the maintenance prevention. I think this is very important. So how do we prevent the maintenance failures? Which means what can I do in the machine design stage? Proactively, even before building the machine, putting into the mass production trials, how can I enforce certain controls in the machine, improving the fixture, improving the quality of structure, and introducing certain POK, therefore the machine doesn't fail. And finally, the total productive maintenance is the final result. What it means is, it is everybody's responsibility. So typically, these TPM, PM started in United States, and the Japanese added the concept of autonomous maintenance, meaning oiling, lubrication, and cleaning by the operators themselves. Therefore, this became a total productive maintenance, which again came back in a big way in US in 1970s, 80s, and it really changed the way how the manufacturing operates, and it gave the world unbelievable results. I think those days we used to have the OEEs at 30%, 20%, After the PM came, the OEs jumped to 70, 80, 90, 95. And today companies are raising at assembly lines close to 100% and machining lines above 95% on the global lines. So that's the kind of evaluation of TPM, which means the operator from the manufacturing side participates. It's a team activity, and therefore it is teamwork together with maintenance. Next, please. So what TPM is not, basically a maintenance department program, just a workshop or an event, a way to eliminate skilled trades like maintenance staff or technicians, making operators and office staff into skilled tradesmen. They're all not part of TPM. Next. The goals of TPM is zero bad, zero breakdown, zero accidents, and zero defects. Next. So I think I don't have to talk about it. The benefits increased uptime of the machines, increased plant capacity, lower maintenance and production costs, lower defects, enhanced job satisfaction. Next. I think the most important thing, the single important thing in TPM is visualization. Everything should be made naked, which means the machines should be completely strip open and everything is visualized. I think when you walk through the plant, typical TPM plant, defect rates, the delivery performance, the daily rejections, the supplier quality, the machine breakdown rates, MTBF, MTTR, everything is completely visualized. Accidents starting from safety, then suggestions. It's an employee participation program. Therefore, everything is visualized so that everybody is able to see the trends and take adequate proactive countermeasures. So this is the starting point. Next, please. And again, visualization. Everything is visualized in the form of pictures and physical platforms. For example, indicates the direction of adjustments on the right side or the left side, where to turn the knob. Quick and safe and troubleshooting things are standardized, and visual controls to improve the ease of operations. Like everything is visualized. No need to worry about what to do. It is visual. You can see by eyes, you can hear by sounds, you can smell by your nose, you can touch by your hand. All these things are visualized in the shop. Next. I think TPM matrix, equipment losses analysis and OEE. I think Dr. Devarajan talked about all these losses. He talked about several losses. But TPM, we talk about 6 big losses. The breakdowns and setups, then the tool setup losses and minor stoppages. I think minor stoppages, we call it as chokote in Japanese. Actually, it is not a big breakdown. It's an irritation to the operator. For example, a tool waiting for, some kind of coolant clogging, or let us say the door is not closing, some chip is getting entangled. So you remove the chip from the door, it operates, but it results in 1 or 2 minutes stoppage. For example, let us say coolant level is low, coolant has to be topped up frequent because of the leakages. Then it's an irritation. You have to pop up the coolant, so you lose the time. So that's what we call the minor stoppage. Then you have reduced speed loss. Speed loss is basically 2 types of speed losses. One is the machine speed loss and operator speed loss. For example, the rapid rates G0 in X, Y, Z and the B axis have been reduced. For example, from 50 meters per minute to 10 meters or 15 meters. I think what we call the machine speed loss for a period of time. The operator speed loss is loss of standardized work time. Operator get fatigued or some kind of cultural issues or slow motion operations or some union issues. Many things are all called the speed losses by the operators. So collectively, it is the speed loss. Then defects and rework, which I don't have to talk about. Then startup and yield loss, which is nothing but some honing machines you need to have some idling cycles, jogging cycles in the beginning, or in a typical die casting plant also you have a jogging cycle. All these things are yield losses. So OE is a very interesting formula. The overall equipment effectiveness, it is the multiplication of availability, performance rate, and quality rate. availability is decided by the breakdowns and setup times. See, it's very simple. I will get back to the calculations later in the next slide. So you just remember that availability is determined by setup times and breakdown times. Performance rate is determined by the losses, speed losses, and mission speed and operator speed losses. Again, which is a function of ideal cycle times and the actual cycle times. Then the quality losses, it means good product rate, which is the net yield of the production operations. So, in a big picture, what I want to say, let us say you got 500 minutes total. Let us say 10 minutes is coffee time and 2 times a shift. So you lose the 10 minutes. So loading time is 490 minutes. So the 490 minutes is the loading time. Then let us say you have a breakdown of 30 minutes and another 10 minutes of setup time. So setup time and breakdown time put together 40 minutes. So 490 minus 40, 450. So 450 is the basic net time available, right? So the total time, that is total net time, which is 450 divided by available time 490. That is nothing but availability. So it becomes a very simple thing. Anyway, I will not worry much now. And again, even if you reduce the setup time and the breakdown time, still you don't get 100% output because you have got machine speed loss and operator speed loss. That is why ideal cycle time to actual cycle time, theoretical cycle time to the actual cycle time, the cycle time set at the beginning in the ideal condition to the actual current cycle time, that ratio is a machine speed loss. And you multiply the actual output by the ideal cycle time divided by the net time, still you won't get 100% there because the losses are happening due to speed losses, due to minor stoppages. Again, this is what we need to understand a little more deeply. I'll come to that later. I just thought I'll give you a big picture. Next, please. Yeah, the 6 big losses I just explained. I don't want to touch much upon. Next, please. So improvement goals is, as I said, zero. Breakdown should be zero. Setup and adjustment losses should be minimal. Should set global targets. We talk about single minute exchange of dies on a global platform. And adjustment losses should be basically zero. And the setup should be in single digit. Speed losses should be zero. And idling and minor stoppages should be zero. Quality defects and rework losses zero. Startup losses should be minimal. According to me, it should be zero. Next, please. So OE is the availability into performance rate into quality rate. I told in the earlier slide, availability is determined by breakdown and setup time, and performance rate determined by the idling and minor stoppages and reduced speed losses, and quality rate determined by the quality defects and rework losses and startup losses. So availability is the ratio of the operation time to the loading time. So loading time is very simple. You have to subtract the coffee time or the plant time. Let us say out of 500 minutes, 10 minutes, 5 minutes, 5 minutes coffee time, 490 is the loading time. So loading time minus whatever breakdown or setups, you subtract it and divide it. That is the availability. As simple as that. I think it's a very simple formula. You don't have to worry much about it. Next. So I think I've explained very clearly. I don't think you need any explanation. Performance rate is the rate of the product of the operating rate into net operating time. Don't worry about it. One simple formula, if you look at it, it is the multiplication of operation speed rate and net operation rate. See, I've given the formula here. Ideal cycle time by actual cycle time is equal to operation speed rate. So originally at the time of showroom condition, when you set up the machine for the first time, you have set up a cycle time of 2 minutes. The cycle time has increased to 3 minutes because of rapid traverse has increased, machines have slowed down. So your operation speed rate is 2 divided by 367%, as simple as it. And is also the next factor is net operation rate, which is output multiplied by actual cycle time divided by the loading time. So I think this it's a very simple formula. So what I'm trying to say, imagine this denominator is nothing but 490 minutes is already available, minus breakdowns and setup. I told another 40 minutes we lose. So the denominator is nothing but 450 minutes. But even if you put 450 minutes, you have subtracted breakdown and setup, and the numerator, you multiply the actual output into actual cycle time, still this is not 100, or this still it is not 1. Why? Because minor stoppages cannot be visualized. For example, 1 minute you lost because the coolant tray is stuck or door is not closing. So that is where net operating rate is capturing the minor stoppage. The very important thing all of you should understand. Why it is with net operating rate is important? Because it captures minor stoppages. And minor stoppages is the biggest enemy of TPM. And what can solve the minor stoppage? Only oiling, lubrication, and cleaning, autonomous maintenance by manufacturing, by operators. I think this is a very powerful concept you should understand. I think you will have a lot of doubts. If you have doubts, please ask me. And if you really look at, just go back, this formula, if you see multiplication of operation speed rate and net operation rate, actually if you multiply the actual cycle time and actual cycle time get cancelled. One in the numerator, one in the denominator. So then the performance rate is nothing but output multiplied by ideal cycle time, output multiplied by ideal cycle time divided by the net available time. Means it captures minor stoppages and speed losses. I think if you have understood this equation, it's fantastic. I think you achieved everything. But to understand this equation, you may be not very clear, but feel free to ask me. I can tell you later also. Did you understand this, gentlemen? I'm sure the TPM people practicing TPM should understand this. Okay, let us come to the Q&A later. Let's go to the next slide. Please note down your doubts. Yeah, so OE is multiplication of quality rate is simple, output minus number of defects by output. So ideally, whatever you produce, 100 numbers you produce, all the 100 should be okay. If 2 numbers are defective, your quality rate is 98%. Therefore, OE is equal to multiplication of 3, which is availability into performance rate into quality rate. So this is a beautiful formula. Interestingly, when I did this research in my B school at IIMB, I tried to survey some of the government public sectors. I was very shocked to see the OEs were for 10 and 15%. And when I typically looked at some private sectors, they were at 50-55%. Then I imagined the kind of losses happening in the industries. That really prompted me to study deeper and deeper on this. And I benchmarked several companies like Sundaram Fasteners. They were implementing TPM in a big way. And I think it was a great journey for me. And today I'm very happy to see companies, not only the 6 big losses, but as Dr. Devarajan said, the breakdown setup, minor stoppages, speed losses, yield losses, quality losses, management losses, tool losses, die losses, logistics losses, raw material losses, all losses put together. The net of thing, I think the global targets in Toyota, we were able to achieve 95%, 98% comfortably in machining lines. That's a global target, and 95% close to that in the machining lines and 98% in the assembly lines. This is a fantastic number. If you're able to focus on this, I think sky is not the limit. In fact, I remember still my days in Toyota Auto Parts. Prakash will agree. Those days, 2 to 3 years, I tried to focus on operation rate, the speed losses. I coined the word speed losses. Then every line I used to visualize all these losses. And over a period of time, I think the plant performance improved dramatically. And I think unbelievable journey we had. And quality losses we could dramatically reduce. And today, I think I'm very happy to see that Toyota Kirloskar Auto Parts is one of the best global plants. They have achieved almost gold in every areas in the three pillar activities. And I can assure you, I think if you focus on this OEE, it's a visualized, measurable tool to management. You can capture all single losses in a single formula. See, unlike TPM and other areas, TPM is measurable, visualized. OEE improves by 1%, the entire efficiency, the profitability of the organization increases, visible to the top management. And you can see a very clear-cut growth in the top line and bottom line. Next, please. So, I think, okay, let me just take this example. Let us say loading time is 460 minutes in a typical 8-hour shift. Let us say no coffee time, tea time. I think they have given 0 in the example. Let us say downtime and setup times are 20 minutes, 20 minutes. Tool change time is another 20 minutes. So what is the net operation time? It is 460 minus 20 plus 20 plus 20. It is 400 minutes. And let's say ideal cycle time at the time of setting up the plant is 1.5. Due to some increase in G0 or rapid traverse in X, Y, Z and B axis, it has increased to 1.8 minutes. Therefore, the output is, let us say, it's coming 200 numbers per shift, right? The number of defects is 8 parts. So what is the availability? Availability is nothing but operating time 400 divided by loading time 460 minutes into 100, 86.95. Operation speed rate is nothing but ideal cycle time by actual cycle time 1.5 by 1.83%. Net operation rate is nothing but actual output multiplied by the actual cycle time divided by 400 is 90%. The performance rate is multiplication of operation speed rate and net operating rate. It is 83 multiplied by 90 is 74%. Quality rate is 200 minus 8 divided by 200, 96%. Therefore, OEE multiplication of all these 4 is how much you have not calculated the OEE, I'm sorry. So you can calculate by yourself 86 multiplied by 80 multiplied by 90 multiplied 74 by 96. Can somebody multiply this? It is less than 50%. 86 multiplied by 83 multiplied by 90 multiplied by 74 multiplied by 96. How much? Prakash, can you help me out?
Yes, sir. Just a minute. I think I'm trying to do that.
It takes only 1 second.
It is little 0.74. It is less than 50%, sir.
Yeah.
40,
See,
43, 44.
okay. Let's go on. So I think what I want to say is, you may think that you are operating at a very high level. Oh, I have got 86% availability. I got a fantastic 90% operating rate. My quality rate 96%. But please understand, still your OE is less than 50%. I think this is the kind of message to the top management. So imagine your OE jumps to 95%. Look at the performance improvement. You're almost doubling the performance of the plant. That's the power of OE. Next. So the improvement goal for the 6 big losses: break down 0 setups and adjustments, minimize single minute exchange of dies, how to simplify internal elements into external elements, so that without stopping the machine, you can do all the setups outside. That's where the single minute exchange of dies. You can read that Shigo Shinge, the book of SMED. Then reduce speed is 0, minus stoppage is 0, defects and rework 0, startup loss, I think it should be 0 according to me. So this kind of targets is very, very important. These are all global targets. And let me just come to the 8 pillars of TPM. I think Dr. Devarajan touched upon. I'm going to briefly touch upon these pillars. Let me tell you, gentlemen, the foundation for this is 5S. And the daily management through the 3 pillar activity is the foundation. What is 3 pillar? I think 3 things. One is the standardized work. This is the foundation. How to perform the standardized work in the decided way by all the operators. I think be it in the maintenance activity, be it in the operations activity, be it in the quality activity. I think there should be standards to perform the job, and we should do it as per the standards. Then standardized work, process point management, then cutting point management. So all these three things are very, very important. So 3 pillars is nothing but standardized work plus process point management. All these things are coming under the process point management. You have got quality point management, machine point management, then maintenance, the total $1,000 of the maintenance management. All these things are coming under process, die point management, all these things. Finally, the tool point management is the third pillar. How to ensure tools are given on time, how to achieve 100% direct pass through the tools, how to reduce the tool setup time. All those things are coming under the tool point management. Therefore, 3 pillar is standardized work, which is the foundation, which is nothing but again the foundation is 4S, starting from 1S. Then you have the process point, then you have the tool point management. This is another big subject by itself. Prakash is going to take a session on this very shortly. So the power is something unbelievable power. So we can learn more through a separate session. So the 8 pillars: safety, health, autonomous maintenance, plant maintenance, focused improvement, early equipment management, quality maintenance, education and training, and office TPM. So let us talk about them briefly. And as I said, the foundation is 5 years. I think let us go to the next slide. Next slide, please. Yes. Okay, I don't have to talk about, you're all champions of 5 years. I think I will skip this slide because this is the foundation of any workplace. Next. See, just to tell you, let me tell you, first to do this 5 years, you should do the first 1S. What is not required, please throw mercilessly. If you don't do that, you will never be able to enter even 1S. Entire steps will be a failure. I think this is the power of management, right from the top management should have the guts to ensure that what is required and what is not required, and not required things should be thrown out, because anything that is not required is a muda. It occupies space, it occupies management time, you need to maintain them, and it creates so much of confusion and sorting. And second is whatever is required, please systematically arrange them. That's very, very important. Third, not only required things in arranged way, you should keep them spick and span, clean, tidiness, in good condition. Not only cleanliness, you should standardize, which means there should be a standards for your forests. What should be the cleaning levels, how the racks should be, what should be the height of the racks, how should be the retrieval mechanism. All those things should be standardized. That is Saikitsu. Then finally Shitsuke. The discipline is nothing but self-discipline. It is a training. What kind of rules are available, and how do you ensure that you follow the rules all the time? I think that this is a big subject by itself. But most importantly, first S is very, very important. Then normally it is only 4S. The fifth S is Shitsuke, or the discipline. I jovially say to practice 5 years, you should have your own personal 5 years. Starting from first S is you should every day have a shower. Second S, you should have a shave every day. Your body is like a machine. Third S is you should change the socks every day for the benefit of others. The fourth S is smile. I think always the smile is very, very important. Smile spreads a very positive aura. Before the smile is the last test, that is discipline. You should also change your shirts every day. So I tell my friends in the shop floor, please practice this 5 years every day, yourself 5 years. Then you can enter the first test. So I think if you yourself is very clumsy, you don't change your shirt, socks, full of body, full of oil, in that area, never you will be able to maintain that 5 years. So in a jovial spirit, I told, but I think every yes has got a huge meaning, starting from the first yes. Next. So sorting is a big activity. You need to sort necessary and unnecessary items, and unnecessary items to be disposed immediately, and whichever items not used for a long time should be kept separate or thrown out. And again, unnecessary items need to be segregated and disposed in the respective bins. I think this is a great subject. Let me tell you, gentlemen, if you are able to master 4S, leave the 50S, 5S is a discipline. If you are able to master this 4S or the 5S, I will give it in bond paper. Your company will be a world-class company. You don't have to do anything else. This is the starting point of a big revolution, cultural revolution. It's a paradigm shift, I would say, because in my 35 years plus experience in the operations, in manufacturing, in various areas, in corporate life, I think the company that practices this is a great success, and the consistency is our biggest enemy. We are very good in one day international. Our biggest problem is the 5th year, the self-discipline. We don't practice it. I think given the smallest chance, we deviate rules. I think let me tell you one interesting things. I talked about the 5th year, the discipline, follow the rules. All the time when you walk through the shop floor, please ask these 3 questions. Is there a rule? First question. If there is no rule, please, ladies and gentlemen, make the rule. Somebody asked, in India, all the trains are running late. Why do you need a railway timetable? You should know that the train is running late. No? That is the starting point. That is the first. Rules should be there to visualize the normal and abnormal. The rule is this. So I am here, it is abnormal. I am here, it is abnormal. I think to visualize that, you need the rule or the standard. That is the starting point. Second, you have the rule, but people don't follow rules. Why? Because the rule is difficult to follow. Therefore, simplify the rule. If I cannot follow the rule, I don't expect my subordinate to follow the rule. Therefore, rules should be simplified, easy to follow all the time. That is when we talk about Muri, Mura, and Muda in Japanese. In TPS, it's a big parlance. Muri is unevenness, impossible things. Mura is unevenness, and Muda is a waste. So all these things are arrived out of this. So check whether rule is available. If not, make the rule or the target or the standard. Second, rule is available, still people don't follow the rule because, please ask, is it difficult to follow? If it is difficult, simplify the rule by Kaizen, so that everybody follow all the time. Third, rule is available, rule is followed by people. So rule is easy to follow, still people don't follow. Why? Because rule is not understood. Training has not happened. Therefore, whenever you see any abnormality in your office, shop floor, institution, wherever, please ask these 3 questions. Is there a rule? Is the rule easy to follow? Is the rule trained properly? Then you can get the results. Once you achieve the root cause and solution, then it is easy to implement. Next, please. So this is sit-down, systematic arrangement of things. So look at the left side. Terrible. Cleanliness is godliness. Look at the right side. How happy place. I will tell you one thing. If a table is spick and span, I will give it in bond paper. Your life is very successful. You open your drawer, you get rats, life is hell. It has happened to many people. In one government office, when I was we were trying to open one this thing, 2-3 rats were coming, small rats. Many places it is happening. Please ask this question. If you open, see, that is why in the 3 pillar, in the 4S, the fundamental thing is table. Once I open the table, unnecessary things are not there. Necessary things are put in a systematic way, in easy, clean way. It is like a temple. You open that drawer, stapler one place, clips one place, writing pads one place. Actually, you feel happiness. You feel like working. I think, please, this is very important. That is why this example is there. Next, please. Clean up. Keep workplace and surrounding clean. Clean waste and dirt. Dirt is generated due to oil spillage from equipment, throwing unnecessary packing materials will also result in accumulation of dirt. I think dirt is the root cause of several things. It is the root cause of corrosion. Dust covers many problems. So our challenge is root cause is dust or dirt. How to eliminate dirt? Ultimately, there should not be any cleaning. It should be natural. Best is no cleaning. Why should you clean? Cleaning is a Buddha. First step is to clean. Ultimate destination is to eliminate cleaning so that dirt is completely and fully eliminated. Next, please. Standardize. See, the most important thing is abnormality should be visualized. Therefore, rules should be there for everything, or standard should be available. For example, if I have a glove stand for keeping the gloves, what is the maximum and minimum? That is the kind of standard. Right? For storing, let us say, papers, what is the maximum, minimum? To what level I should store? And once the rules are available, standards are available, it's much easier to follow. No obstacles. Next, please. And finally, the fifth is self-discipline. Rules are easy to understand, follow. Rules are easy to maintain. There is someone to check everybody is following the rules or not. Ultimately, it should become self-sustaining. Nobody should check. I should be checking myself. If somebody checks me, it is a shame on me. In fact, in Japan, somebody tries to check the other person, it is like a sad phenomenon. It's an insult to people. There is no second conductor in the bus. People buy their own tickets. People do their own checking. I think that is the best way. That is the next level of Shitsuke. That beyond rules. Next, please. So benefits of 5 years, I don't have to tell you. 0 accidents and great workplace and happy feeling and improves the productivity. Let me tell you, wherever the 5 years is established, that places will reach global excellence. This is a real eternal truth. I can tell you, where it is sincerely practiced. Not like ISO. ISO means, I always say, I stay in the office before the day of the audit. The auditor goes away, immediately the mountains will come. So ISO, no, not ISO. Every time it should be like the showroom condition, not when the auditor comes. So I think that is the ideal situation. Do you agree with me? So far, any doubts, gentlemen? I've been talking. My speed is okay?
Yes, sir. I think we are running short of time, so you may have to look at a few more
Yeah. No,
team
I don't know. I'm just trying to
but so
connect.
far we have not received any questions, so I think it is quite.
There are two ways of understanding. No questions means they understood thoroughly, or the people are not understood at all.
No. I think your examples
Okay.
beyond the slides, what are there? I think they're all listening very carefully. Not just the slides, but I think beyond the slides.
And if you feel like sleepy, please tell me. I can give a rest for 5
No.
minutes.
It's not.
Thanks a lot.
So,
Thank you.
so we are right now at 4:40, sir. We have another 20 minutes to go before we go take up for a Q&A.
No, I think our session is from 3:30 to 5:30, right?
5:15 is the time.
Okay. Let me try to see whether I can complete by 5 o'clock. Then we can have a Q&A. Okay.
Right. Yeah.
Next.
Thank you.
Next, please. See that the daily management is very, very important. I think this is the mother of everything, be it TPS, TPM, or TPM. Daily management by the team members, by the team leaders or the supervisors, by the group leaders, starting from safety, quality, safety, environment, quality, productivity, cost. All the key main KPI, sub KPI, and the process KPI. and the challenges. I think this is a daily management you can see in any of our plants. This kind of daily management is the base of everything. That is the base of three-pillar activity. Everywhere the problems are visualized. Therefore, it is cleaning leads to checking, and checking leads to our detection of abnormalities. Detection of abnormalities leads to positive effects or countermeasures, and countermeasures leads to positive effect. Positive effect leads to detect pride in the workplace, and it is a continuous cycle. So why this started? Daily management for strengthening the daily shop floor management and to meet the customer expectation. So of course, in all the plants it is standardized. So if you can see on the right side, I talked about three pillars: standardized work, ownership maintenance, and assembly point management, cutting point management, or die point management. So the three pillars, the left pillar is the standardized work. So I said the process point, nothing but the ownership maintenance. This is nothing but, please correct it, the ownership maintenance is nothing but a TPM, kind of a TPM activity, which is much beyond. I think it has a Senmonhosen, then the maintenance management, and many other pillars, sub-pillars. So ownership maintenance is nothing but TPM, you can imagine. Left side is the standardized work, how to perform the standardized work. Right side is various point management. Let us say tool point management, weld point management, assembly point management, quality point management, logistics point management, right? It is point management. So the three pillars are standardized work, ownership maintenance, and point management. Sorry, I think I said the process management in the last this thing. I'll stand corrected. Sorry, it was a, while spelling it out, I said it wrongly. I recollect it now. Next, please. So this three-pillar originated in the Comico plant of Toyota. From there, it has become a huge movement by itself. Today, let me tell you, we are able to save billions of dollars globally through these three-pillar activities. We are trying to take it up to several suppliers across the world, and we have seen 100-200% improved results in very, very short times. And there are three levels: gold, silver, and bronze. Bronze is the basic level where there is a system. Systems are established. Silver is where we make improvements based on the systems. Because we set targets, we visualize the abnormalities, we make the Kaizen a level up activity. So this is, we make Kaizens and rotate PDCA. PDCA means plan, do, check, act, and we increase the target level and keep achieving, improving the level. First basic level is bronze, silver is Kaizen and level up, and gold is the global level, the challenging the global levels on safety, quality, productivity, and several other parameters. For example, zero accidents, zero incidents, zero rejections, zero customer complaints, those kind of levels. Rejections, of course, 0.002. That's kind of a level. And rotating the PDCA all the time. Jovially, I say PDCA means please do not change anything, but you have to rotate it. Plan, do, check, act, increase the target, do Kaizen, go up, increase the target, go up. So your spiral should go across the slope. Next, please. So this three pillar I told about: safety, quality, productivity, cost, HRD in every line. And basically main KPI, process KPI. Actually main KPI, then there should be sub KPI, then process KPI. To achieve the process KPI, what activity is driving them? Therefore, activity KPI. For example, if you have to achieve a zero accident is the main KPI, then I should say, let us say 100% of the time people follow the PPE. That is a sub KPI, right? Main KPI, sub KPI. Then what is the process KPI? Process KPI is, let us say that we have a kind of audit system. Let us say we audit non-compliance should be zero. Then the activity itself is how many times you audited. In the plan was 5, actual was 3. Why the gap is there? Therefore, in the enriched triangle, activity should drive the process process should drive the sub KPI and sub KPI should drive the main KPI. And again, this is how the whole system is visualized. System is bronze, process or rotation of PDC is silver, and result is gold. And ultimately, in all the key areas, it is visualized. Therefore, the entire plant is a level of activity. Next, please. So, key pillars of TPM. Again, 8 pillars. You can see 4 pillars on the left side and 4 pillars on the right side. Safety, health, environment is the first pillar. I think everything starts from the safety. Safety first. We say quality must. And if you look at our plants, even including starting from the commutation bus, all the buses have seat belts installed in all the buses. And safety is the mantra. Safety is the order of the day. Everything starts from safety. If there is no safety, no Gemba, no operations. I think health and environment are equally important. Then the second pillar is autonomous maintenance. Autonomous maintenance is oiling, lubrication, and cleaning by the shop floor operators in conjunction with the maintenance team at the elementary level. Then do basic maintenance activities through the 7 steps of autonomous maintenance, which I'll touch upon later. Then you have the planned maintenance activity, which is very important. It is a huge improvement of planned maintenance activities through which you're able to improve your mean time to restore and mean time between failures, MTTR and MTBF, and you race towards the global targets. Then focused improvement by improving the fixture or the jig or the physical mechanism of the machine, you're able to enhance the machine efficiency. Then the fifth pillar is early equipment management, which means front loading of the problems. Typically in Indian companies, we start the projects in no time. Within 2 minutes, the project starts. But for the rest of the lifetime, you keep on struggling with problems. But if you look at a Toyota plant, we set up the plant for nearly 1 year. Machines, they come, we conduct all the process trials, establish all KPIs, achieve mission process capability, mission, process mission capability, process capability indexes, fine tune. Once it is set up, all the problems are visualized, early loading of the problems, then it looks like a showroom condition. Zoom, it goes OE at 95%, 98% of the assembly lines and 95% of the machining lines. This is one great thing. That is the early equipment management, which means problems are loaded in the front, therefore problems are minimized at the rear. Then quality maintenance, which is again a quality 3 pillar, is a great pillar. It is a complete TQM journey plus alpha. And I think it is 1 or 2 days are required because this itself is a huge pillar. Because how quality maintenance, how manuals are written, how quality rules are framed, how every quality has got a standard, how each step is visualized as a rule, how the rules are trained to the people, how these trained documents are made more simpler. Over a period of time, these rules should come down and implementation should go up. Ultimately, it should become self-sustainable. I think this is a great management strategy. Then education and training. I think education and training is the base of everything. People, people, and people. There is nothing other than people development. And if you cannot develop people, nothing is going to happen. And our former president of Toyota Motor Corporation said, the shortest journey for a company's prosperity is people development. People, people, and people. All the time, I think training, retraining, level up, level up, level up. I think sky is not the limit. And training is never ending for every level. Office TPM is a great thing. So whatever shop floor is happening, same thing we have also implemented in our office side. All documents are standardized. Ledgers are standardized. All our programs are standardized. All our filings, all our computer softwares are all standardized. All our documentation storage are all numbered and standardized. Retrieval mechanism, any document can be retrieved in seconds. There is a standard for that. Then there is an elemental time for every activity, office activity. For example, if you have to make a purchase order, standard cycle time is available. If you have to make a rule, then that rule will say what is the standard time to implement that document. So which means this is office TPM. when we started the office TPM, we found innumerable benefits, and it's amazing low-hanging fruits were there. We could reduce close to 50% of the people. That kind of number I could say. Therefore, office TPM is a great learning. I think we call it as Gyokaku in Japanese. Gyo means office and kaku is reforms, office reforms or business reforms. So I think Gyokaku, we have taken nearly 3 years to implement, but it was a great journey. So I can talk about it much later. Next slide, please. So safety and health, zero accidents, zero incidents. I think this is the base of everything. Everything is visualized. A lot of slogans, posters, work motivation programs. Every rules are visualized. Safety rules. Yours check. Left okay, right okay, straight okay. No telephone while walking. All these things are visualized. And safety mind is very, very important. Starting from zero accidents. Right? You can give any number of countermeasures for safety, but if you don't have safety in mind, nothing is going to work. Therefore, how to develop the safety consciousness, that is the key. And our Toyota culture, if you look at, we have a gate, quality, a safety gate. The front side, it is written like this. Safety work, safe work is the door to all the work. Let us pass through this door always. Safe work, reliable work, and skilled work. On this front entrance, back side, it will say, thank you for following safety. Follow safety rule every time. Because if we cannot have a safe workplace, the accidents are going to happen, quality problems are going to happen, customer issues are going to happen, and you are going to have IR issues also. And there will be a lot of chaotic frustration across the plant. That is for sure. Next. Walking safety. No, like do use check at intersections. Right okay, left okay, before you cross all the points. Do not use mobile phone. Walk on the walkway and use zebra crossing. Do not put hands in your pocket while walking. Use handrails while climbing. This is the standard safety rules in any Toyota plant anywhere in the world. This is a standard. And this is a mantra all of us have to follow everywhere. Next, please. So accident is nothing but unwanted event which may not create an injury, but it can damage or it can create an injury or both. So accidents can happen due to several reasons: lack of concentration, less skill, urgency, carelessness, negligence, worries, fatigue, illness, not following PPE safety rules, overconfidence, etc. Next. Accident causes maybe, there are two reasons. One is unsafe condition and unsafe action. Unsafe action and unsafe condition. If you really look at 80% of the accidents are happening due to unsafe action. And if you really look at 80%, and 18% due to unsafe condition, and 2% due to natural calamities. That is a huge wind, water coming suddenly, all this stuff. Next. So we have the stop 6+2 actuator, big thing, big weight, big like crane. Then C for car, D for drop, H for health, G for gillet, cut injuries, F for fire, E for electric shock. So these are 6+2 big safety causes. Next, 6 big causes. So we do the Kikken-Yoshi training. Kikken is predicting the danger or the forecasting the danger before any activity, any unplanned or any planned activity is done. We do the KY training. We check whether everything is okay. Then we predict the danger. We put the countermeasure. Then there is a shadowing by the senior. Then the actions are written. Then the action is started. This will save a lot of accidents, and 80% what I talked about is coming from here. Next, please. KY training is very important. There are typical examples of KY training. Why accidents happen? Look at it. The person is trying to climb and he'll fall into that pit hole, and all these things are, unsafe acts. Next. Here, Yato is a near-miss accident. It is not an accident. Almost a near-miss accident happened. Therefore, we identify near-miss accidents. We encourage HH. Here, Yato suggestions. What are all the near misses happening? And if you can kill the near-miss accidents, then you can kill the probable minor accidents. If you can kill the minor accidents, you can kill the major accidents, the Enriched triangle. So here, Yato, near-miss is the base. We encourage people to point out. Next. So Lotto is very important. Lotto training where we have a logout and tagout system. Before entering a machine, these logout and tagouts are used so that the controls are completely switched off so that even people enter the mission, there is no accident. So this is again a big system by itself. I'm just touching upon the macros. Next. So this is a logout tagout system where different types are there, where multiple people are involved or single person is involved, the top and bottom. Next. So you can use the right PP for the right place at the right time. I think this is very important to safeguard yourself. Next. And again, the fire is a combination of three elements: oxygen, fuel, and heat. So presence of all the three elements will result in fire. Therefore, each one of them we have to eliminate and prevent. Next. So these are all the various types of classifications of fire. I don't have to touch upon this. Then I'll come to autonomous maintenance, second pillar, oil, lubrication, cleaning. There's nothing but the Jishu Hosen, the base of the maintenance by operators as a part of JH activity. So this is a structured and collaborative approach between maintenance and manufacturing, increasing skill levels of personnel, smoother process flow, achieve optimal conditions to achieve high quality products, eliminate minor stoppages, reactive to proactive maintenance approach. This is very, very important. Next. Then basic autonomous maintenance steps, cleaning, oiling, and lubrication. Next. So as I said, cleaning leads to checking, checking leads to detection of abnormalities, leads to countermeasures, lead to improved performance, and lead to pride in the workplace. And this is a positive PDCA cycle. It starts rotating. Leads to early detection, early resolution. And lubrication, right place and timely lubrication, which results in reduced friction where force deterioration, leading to lesser noise and reliable machine. See, always there are two types of deterioration: force deterioration and natural deterioration. Natural deterioration is due to natural wear and tear, but force deterioration happens due to lack of lubrication, oiling, and cleaning, lack of daily maintenance. Therefore, I think this force deterioration will result in early failures of machines. Therefore, by killing the force deterioration through this autonomous maintenance, you can extend the life of the equipment. Next, please. For example, proper tightening will lead to another oiling, lubrication, and tightening. Similarly, proper tightening will lead to improved rigidity, reduced vibration, chattering, stable emissions, and good part quality. Next, please. So this will lead to prevent equipment deterioration, equipment restoration, proper management, establish ideal condition. Next. So the 7 steps of autonomous maintenance, I don't want to touch upon that because this itself is one full session. But I will say the step 1 is initial cleaning. Step 2 is the countermeasures to sources of contamination. Step 3 is cleaning, tightening, and lubrication standards. 4th is overall inspection after the cleaning. 5th is wear out part replacement based on the autonomous maintenance standards. And 6th step is detection method and frequency of detection. This is basically process quality assurance. And 7th is autonomous maintenance sustenance and PDCA, using all the 5 sensors and how to visualize all these activities so that it becomes self-sustaining activity. So the 7 steps of autonomous maintenance. Next, please. So again, a deep cleaning. I think the deep cleaning is not just cleaning. You go deeper and deeper and deeper. You get into so many problems and you detect those problems like bearing is rattling or bearing is scratched or the bolt is broken. Many things you can discover and you can replace them at an early stage. This deep cleaning has given tremendous results, and deep cleaning is the primary step to restore to ideal condition, after showroom condition when the machine was established. I think again this is a big subject by itself. We can talk on deep cleaning for one full session. I think just understand the word deep cleaning. I think it is much more powerful and meaningful. Next, please. And I think ultimately, cultural development is fundamental skill training on machine elements, on-the-job training, improves relation, working together, improves skills and ability to correct minor stoppages. So the skill up also, there are 5 steps of skill up. Level 1 can able to do deep cleaning with do's and don'ts. Level 2 can do deep cleaning and periodic check and find abnormalities. Level 3 can do and solve minor abnormalities. Step 4 can teach others. And step 5, you are able to sustain and take it to the next level. So there are various levels of deep cleaning activities. I think it is a system called tag on, white tag and red tag. Red tag is when you do the deep cleaning, you detect problems. Some problems can be solved by manufacturing themselves. You put a white tag. Some problems cannot be solved by manufacturing. You put a red tag. So this is called a tag on and tag off system. So this is a part of deep cleaning and maintenance activity. Next, please. So deep cleaning activity leads to early detection and early abnormality. For example, you can see coolant accumulated at axis ball screw, chips accumulated at axis ball screw, solenoid DIN connector came out. All these things are a result of deep cleaning. Next 10 minutes I'll try to complete, then we'll take a Q&A for 10 minutes. Deep cleaning activity, I think this is an example how you have to perform the deep cleaning. I think there is a chart starting from safety and what you should observe in the deep cleaning. Then what is the kind of organization, who is the boss, then what kind of schedule you have to do the deep cleaning, then again summary of the activity, then follow-up activity. There is a sample for this, and it has to be continuously followed up. This is the system. Then autonomous maintenance examples are general inspection. See, the whole idea I said is visualization is the mother of TPM. Everything is visualized. For example, we put the sticker, eye sticker, that particular place, see by your eyes. Then some place you put the ear sticker, please listen some sound at that place, any abnormal sound. Then you put the hand sticker, touch and feel anything abnormal there. Then, so hearing, touching, smelling. No, this is nose, this is ears, this is hands, this is eyes. All the stickers you can see, and what position they should stand, and what they should observe. Everything is standardized. Everything is visualized. And the line mark for the bolt and nut. Anything is displaced, immediately you can visualize. So this marking is very, very meticulously done. And this discipline is very important. Any kind of mismatch, immediately say that bolt and nut is loosened. Next, please. So checklist for autonomous maintenance. You should have a checklist for the PM, where a detailed checklist is there. Check the coolant level, check the heat exchanger fans, check the servo drive fans, check the exchanger air filters, so on and so forth. Then again, activities, who does what? Is it manufacturing or maintenance? For example, breakdowns, robustness improvement, maintenance, effectiveness and appropriate repairs, maintenance. For example, routine maintenance, cleaning, refurbishing, manufacturing, lubrication and tightening, manufacturing. Like that, it should be visualized. Next, please. So stage-wise approach. So we have various stages. First is train the associates on the basic maintenance activities. You have to select a model machine, select the model line. Then Yokoten means horizontally deploy. Once you complete the model line, make it perfect. Learn from that, standardize that particular line. Then you can horizontally deploy to the other lines. Don't try to do many things simultaneously. That's a waste of time, biggest Muda. You focus on one area, complete it, learn from it, then reflect it to other areas. Next, please. Plant maintenance is the third pillar. I think this is to prevent the deterioration, inspections to measure the deterioration, regular operating checkups, and early treatment, correct detections of deterioration. Basically, preventive maintenance. Next. Preventive maintenance is health management for machines. So daily prevention, daily health checkups, and early treatment. So there are various ways. What we should check daily means through daily maintenance, cleaning, checking, lubrication. Then health checkups. It can be done periodically through routine inspections and operating checks. Then early treatment is restoration, deterioration. Whenever you find an abnormality, you have to replace or bring back to original ideal condition. That is early treatment or restoration to original condition. Next. These are all the steps of daily maintenance. I don't have to tell. Then I talked about Senmonhosen, which is the maintenance three pillar, is to build a prevention-oriented system of workplace targeting zero equipment failures and zero accidents. So there are three steps in the zero failure management, focusing on occupational safety and nurturing human resources. One is prediction, second is prevention, third is quick repair. There are three stages in this. Next. So if you really look at prevention, for example, establishment of good facility, improvement of key facility, prevention of malfunctions, recurrence, improvement of good facility, all these things are prevention. Prediction, discover before and correct. Manufacturing, autonomous maintenance support, periodic and quantitative maintenance, predictive maintenance, science management. All these things are predictive in nature. And action is promptly correct, prompt support for repairs of sudden failures, spare parts management, improvement of maintenance skills. Next. So basically, these are all the Sinmo knows and key points. Management indicators are GL control board. For prevention, we create better workplace, better machine, focus on critical machine, prediction, ownership maintenance, and periodical quantitative maintenance. And action, quick action against emergency repair and maintenance skills. All these things are focused on the Sinmo key OSIN points. Thanks. Next. How to make quick repair? I think there are Q6. I will just leave this. Go to the next. See, improve maintenance infrastructure for quick repair. Basically, find the gap from the current situation and the ideal situation, then understand the gap, then analyze the problem, then identify the weak point, then set theme and improve. Something like a A3 paper of problem solving you have to make for improvement themes. Next. So I talked about Q6. Q6 is when problems happen, how to quickly fix it. This is all 6 Bibles, I would say. 6 commandments. Q1 is diagnosis skills, human machine interface, drawing manual. Q2 is spare parts, on hand, ready to use storage condition. Q3 is tools, shop tools, special tools, personal tools, etc. Q4 is maintenance ability, replace, recovery skill, working environment, etc. Q5 is setting ability, adjustment, calibration, data setting, quality concern. Q6 is backup, switching time, only indicate have or have not, or backup mission. All these 6 Q6 are very important, and you have to establish the systems and train people on all the Q6. Next. Yeah, just go up. You can see the example. When the breakdown happens, Q1 comes into picture, diagnosis. Then once the problem is detected, Q2 plus Q3, spare parts or tools, how to solve the problem. Then you look at, Q4, maintenance ability, how quickly you can set it right. And then setting ability is again Q5. Then again, backup is at Q6. The entire thing backup is required. So look at this whole correlation. Next. So I don't want to elaborate on this. You can go through this. Focused pillar 4, focused improvement. Next. This is nothing but Kobetsu Kaizen, what Dr. Devarajan talked about. Individual or focused Kaizen. Kai means change and Zen means good. The principle behind is small improvements lead to a major improvement. Small drops of water make a mighty ocean. Practice concepts of zero losses in every activity. Achieve ZR targets, all the resources. CR means cost reduction targets. Improve overall equipment effectiveness. Focus on early equipment of operators, handling of operators. It's a teamwork ultimately. Then early equipment detection, early equipment management is front loading of problems I talked about earlier. So how the problems are visualized. Earlier, left side is a typical company where problems come in the life cycle. Here the problems on the after I shown, problems are visualized in the initial beginning. Then once the problem line starts running, the problems are almost zero. So this leads to shortening of lead time, reduced total cost, reducing of number of labor hours, and minimizing environmental impact. Next. The last pillar is quality maintenance.
Sir, if I can come in here, just for all the participants today, we also have a session coming up on Saturday from 11 to 1 on TQM, and this will be again taken up by Mr. Parshuraman. So maybe I request all the participants to join for that session as well. That is also going to be quite an exhaustive.
That's a very interesting session. I'm going to talk on TQM and 10 commandments of quality. I think it's an amazing thing that can really level up organizations. I request all of you to spread this and share it in your workplaces. Okay, let's go. So here basically established quality maintenance system, establish zero defect condition, check and measure conditions periodically, and ensure mission geometry like spindle, clamp, force, vibration, backlash, runout. All these things are monitored and visualized. Today we have the IoTs. All these things are dynamically seen. Then early detection, early resolution. We also give this feedback to the supplier sitting in Japan or some other place. We can also order the spare parts, keep them ready, and monitor trends and predict possible failures. Then you can look at improving those spare parts or changing them. All those stuff can happen. Education and training in the seventh pillar. Okay, I think this basically to provide multi-skilling of employees to keep their morale high, versatility, therefore reduce the operation time, and also to reduce the repair time and enhance the skill of the operators and perform their skills effectively and independently. Next, please. Yeah, training to achieve. Go. The 4 levels of operator here is: can you understand training? Can we do with work instruction? Can we do by own? Then can we teach others? These are the 4: level 1, level 2, level 3, level 4. Main focus is to improve the knowledge and skills, create training environment for self-learning, to remove employee fatigue, to make workplace enjoyable. Next. I think this is all examples of various tooling kits in maintenance, hydraulic kits, phono kit, trap machine, where we can create problems on the PLC or the CNC circuit and teach the people. Phono kit, pneumatic kit, electric kit, Siemens training kit, all these things are tools. We call it as training dojos or training equipments. Next, please. So here we make a detailed training plan for various people. You can see the temporary support member, the operators, team leaders, group leaders, what kind of training on safety, self-development, Toyota way, then member knowledge development. All these things are made systematically for their career and trained and methodically. Next. Office TPM, I think I briefly touched upon addressing the 12 major losses: processing loss, cost loss, communication loss, idles loss, setup loss, accuracy loss, equipment breakdown, time spent on retrieval information, non-availability, and correct status. Next. Yokaku is a word, means business reform in English. This is Office 2S, Server 2S, and TAVP is problem solving tool. Any problem in the office side, purchase orders getting delayed, or administration documentation takes more time, create a A3 paper, problem solving paper. That is what we call TIBP, Toyota Institute Business Practice, Toyota Industries Business Practice, right? Server 2S is how to store the files in the server, how to have the shelf life of the server, how to retrieve the file, how to number the file based on the department, then what is the shelf life, then how to fix the capacity of the server, total memory capacity, 5000 GB or 3000 GB, beyond which files will automatically go to the dustbin, like that. Office 2S is very, very important. This will maximize the efficiency of the work and people. I think this is an amazing thing. Let me tell you, we have been practicing Gyokaku for the last 3 years, not 3 years, more than 3 years. I think the kind of results I got, not only in the shop floor, this is the office side, purchase area, HRD, production control, logistics, finance, production engineering. We have reduced the manpower by close to 30-40%, and we have removed unnecessary documents. We have standardized all the documents. I think sky is not the limit, let me tell you. And Gyokaku here is just we have put the schedules, I think setting basic standards, implement sustained standards, then small kaizens, improve efficiency of the workplace, ultimately to man-hour reduction. We started in 17-18, we went to 18-19, 19-20. All standardized work, not only the shop floor, but in the office side. I think this is very, very important. I think both are very important now. Because office side also, we have got 60% indirect staff, many departments. So how to improve the cost efficiency of these departments, performance efficiency of this department. So Target is again we have put in the bottom. Next, basically, ideally, man-hour management, office tours, server tours, and DABB. Here we can see level 1, level 2, level 3 for each activity. Prepare the job K means what is the standard. Then do Kaizen through QCC, DABP, achieve man-hour reduction. Declare standards in the office tours, implement standards, sustain effective resource utilization. Server, standardize and files and folders, reduce space consumption. TABP, report out one for AM and above. Report one for engineering and senior engineering. Report one. So it shows how the reporting to the top management periodically and methodically on the TABP. These are all the level 1, level 2, level 3. So the TABP reporting to lower level, senior level, and higher level like that. Next, please. So TPM implementation. So in summary, evaluate the current TPM level, introductory TPM education and propaganda, form TPM committee, develop TPM implementation plan, stage-wise training of employees, prepare implementation plan, establish TPM policies and goals, and TPM implementation roadmap. Next. So organization starting from the top management, manufacturing head should lead, supported by maintenance, advice from experts. The maintenance manager should have a steering committee and functions like safety, health, autonomous maintenance, plant maintenance, focused improvement, early equipment management, quality maintenance, education training, and office TPM. Next. So this is a schedule. So expected results, OEA improvement, I am telling you, before 90% has gone to 97%. Minor stoppages drastically reduced. Meantime to restore, now we are at 22 minutes from 30 minutes. Meantime between failures from 900 to 1500 hours between every 2 failures. Next, please. Improved morale, self-reliant, and joyful Gemba. I think this is very, very important. Next. So this is evaluation, scoring, and all this. That's it.
I think so, sir.
Okay. Thank you, gentlemen. Sorry, I think what should have been done in a week's time, I tried to make it in 1.5 hours. My apologies. I rushed through.
Sir, I think thank you very much. I think we have one important question from the audience, Mr. Jagadish
Gentlemen,
Kumar.
I got only exactly 10 minutes for Q&A because next session on labor code, I have to open the address. This is by a senior IAS officer.
Sir, only one question. I think this question will be, to both of you, Dr. Devarajan as well as Ms. Parshuraman. Starting with Devarajan, this question is between TPS and TPM, which is better?
See, both are for improvements. Both for improvements. We are all talking about reduction of waste and reduction of. See, one is on the machine to be maintained. Other thing, you are going to have the JIT concept of delivering to the customer. So it is I think both are very, very key for our business. Parishaman?
I think, see, I said in the beginning of my speech, one great thing that I love in TPM, it is tangible, measurable. Like OEE is one single mantra. If I ask you what is the OEE of the plant, 2 things, machine shop and assembly shop, I can immediately measure the plant efficiency. Whereas in a TPS, okay, it's a cultural change. It's a revolutionary change. But OEE is a measurable one. That is why TPM, personally, I love that TPM because it's measurable, quantifiable. Sure. Speed rate, I can ask, what is your speed rate, net speed rate? What is your speed loss? What is the defect? So some of the major KPIs are common, like defect rates, like MTBF, MTTR, all those things may come. But OEE, it is like a single crux of the entire thing is OEE. OEE improves by 1%. The profitability of the plant is increasing by 1%. Bottom line and top line. Therefore, I would say it is like 360. TPM is something like I'm seeing Earth from 1,000 kilometers above the sea level. I'm able to see Earth as a beautiful blue ball. I can put it in my pocket. That is TPM. TPS is a cultural change. It is a manufacturing excellence across the organization.
Right, sir. Sir, thank you very much. I think there are a lot of comments saying that they have actually understood very well and they wanted this kind of sessions to be taken regularly. Since it is almost such a big things, I mean, many things have been put into very brief. So I think there is a request from the audience
I
that
think
it
I have
should be.
covered a 4-year degree course in actually 4 hours only. Me and
Right.
Dr. Devarajan.
No, I
So I
think
think
Actually, we have. Sorry, really,
excellent.
it's very difficult, but I try to, you
I
know.
think you touched upon few things, not only while explaining the slides, but you also explained few of the practical things from the TI, Toyota's point of view. What is it? And some of the Japanese words were also there. Or what is the meaning of that? I think you rightly touched upon it, and I also thank Mr. Devarajan for initially, setting that kind of a context what it means. But when the Parashuraman explained the things, it's even whether it is before, now, or future, all those things remain same irrespective of the changes which is coming, and so base remains same. So the foundation is key. I think that that foundation was touched upon by Parshuramans today. Thank you very much,
See,
sir. I think.
one question is coming. I think
Yeah.
somebody has asked one question. Sorry, I'm not able to attend all the questions. See, somebody talked about some Mission 4.0. Where is it?
Yeah.
Thank you,
Industry
sir. Request your guidance how to level up for Industry 4.0 IoT-based missions TPM. See, let me quickly answer this. See, if you look at our plant, we are connected to all the important machines. We are able to monitor noise, vibration, motor load, temperature, and important sensors on vibrations on typical points. And these are all dynamically seen. And all these signals are coming on the mobile phone. So any changing from the normal condition, and we also put a dynamic performance curve, which means targets are dynamic, not static targets, because we increase the RPM and increase speeds. Dynamic curve we have put target. Therefore, any deviation from the dynamic curve, immediately it is visualized and immediately it is brought to the attention of the maintenance chief. Then periodic maintenance activities are planned. Thereby, we are able to prevent early detection, early resolution. Let me tell you, IoT has been an eye-opener. It is a low-hanging fruit. If organizations don't follow IoT for predictive and preventive maintenance, they are losing huge things. Even the smallest company can use this. Today, it is available almost for free. Therefore, my suggestion, Dr. Devarajan has done a doctorate on this. Their plans are amazing. Our plans also done a lot of studies. Please use them. That's my
Right,
answer.
sir. Thank you very much. I think, as I said, for all the participants, we have following session coming up on Saturday on TQM by Parashuraman only. And followed by that, I think we will have a much more deeper sessions on three pillar and the next Saturday. Not this coming Saturday, but next Saturday, that is on 7th August. So I request all the participants and the members to attend that session. Thank you very much, sir. Both
Now,
of you
let me,
now.
as wearing the president's cap, I have to congratulate Prakash ji, chairman of manufacturing committee, and Dr. Devarajan for this wonderful session. I think a really
Oh,
value-adding session.
Thank you very
Thank
much,
you.
sir. I think. Thank you.
Congratulate. And I
Sir.
want this kind of sessions to happen for the benefit of members. Because
Sure.
as young engineers, young managers, I think all of you should dive deeper and deeper and deeper. And I think once you practice this on a physical platform, I think you can see huge benefits in your organization. I can assure you that.
Yes.
Sure, sir. Thank you. Thank you very much. I think since you are very busy now, you have to go for the other session. So I request this session to be end with Prithvi sir. Prithvi, are you there?
Yeah, very much there, sir. Thank you, President sir and Dr. Devarajan's wonderful presentation. Actually, this goes to almost a week's time class for this, step by step. But you compiled it very well, and need to also thank Prakash for really matching to your presentations, and then he was also able to guide a lot of initiatives on this. So, as a token of appreciation from the chamber, we will also like to give a memento to you, sir. Please accept it,
To
sir.
me,
Yeah, to you and to Dr.
you again,
Devarajan.
yeah.
Yeah, as a
No, no,
speaker,
no.
as a speaker, as a speaker.
It is.
It is
You
a
have
good
only set
practice,
the
sir.
standard, so you
So
have to
we have
follow
to
it.
maintain that.
I should
And
not be getting any momentum from the chambers.
No, no, no. It's
yeah, so
time.
so- and then
Anyway, thank you all. Thank you very
thank you
much.
all.
I
Yeah,
think,
and
thank
after
you
this
all.
we'll have the national anthem played, sir.
Thank you. Thank you.
And Dr. Devarajan, thank you so much. I
Thank you.
Thank
think
you.
on
Thank
behalf
you
of
very
the
much.
chambers,
Thank
we
you.
present a memento to Dr. Devarajan. Thank you so
Yes,
much.
yes,
Thank
yes.
you. Thank you very much. Thank you.
Thank you. Prithvi, that's it.
So we'll have the national anthem played.
Yeah, of course.
Yes.
जनगण मन अधिनायक जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all.
Thank you. Thank you all. Thank you.
Thank you. Thank you once again. Thank you.